Yes, good morning children. Let us continue the class. You might have seen various kinds of sophisticated machines. However, most of these machines are combinations of certain simple machines which help us to do the work faster with less effort. A knife, a screw, a pair of tongs and a pair of scissors are examples of simple machines. So you can see here, all of you have seen this. What is this? This is a pair of scissors. And this we are going to help in cutting things, isn't it? Either paper or cloth or anything. So you are taking the pair of scissors and you are going to cut it. So it's a simple mission. You know this? This is nothing but a knife which helps in cutting fruits, vegetables, green leaf vegetables and all those things, isn't it? So this is a knife which is a simple mission. So you see tongs I didn't get, okay. Then screws, you can see the screws, see it's a big screw, you can see here, isn't it? Yes, these are the simple machines. Now, why we use machines? What is the purpose of using machines? We use machines because they help us in the following ways. Machines help us to overcome a larger force with a smaller force, isn't it? A larger force is done with a smaller force. You don't have to use more effort, more energy. With less effort, you can do it. So, for that reason, machines are required. For example, a car can be lifted with the help of a screw jack while changing punctured tires. So, if the tire is punctured, you can see the jack here. Can you see the jack here? So, what can you do? You can just slowly lift the car up. With your hand, it is not easy to lift. So, when you place a jack, what happens? You can slowly lift the car up and you can remove the tire and replace it. Understood? So, for that, the jack is used. So, you see here, yeah, a car can be lifted with the help of a screw jack while changing punctured tires. Machines help us in applying force in a more convenient direction, isn't it? In more convenient direction. Anyway, whichever direction you want to move, these machines will help you to move. For example, a rope passing over a pulley is used to pull a bucket of water from the well. Without the pulley, we need to apply force against the direction of the gravitational force in order to pull the bucket up. When we use a pulley, the force we apply to pull the bucket is in the direction of the gravitational force, which requires lesser effort. See here. Now you can see this lady. She has tied a bucket to a rope and here this is called as pulley. Understood? It's like a wheel. So what happens through this wheel or through the pulley, she is putting the bucket down into the well. So what happens? Once the water is filled in the bucket, it is not easy for her to draw easily. She cannot do. But if there is a pulley, what happens? This is a mission here. This pulley will start rotating, which helps her to pull the bucket, filled bucket easily. If not, it is very difficult to remove the filled bucket from the well without pulley. So this pulley is making her to work easily. Okay. And even the time also will be less, with lesser effort. So that is what is said here. Once again I will tell you. What is it? See here. A rope passing over a pulley is used to pull a bucket of water from the well. Without the pulley, we need to apply force against the direction of the gravitational force. So what is happening when you are pulling up? So it is against the gravitational force. I told you, anything that you just drop, what happens? It has to come down. It cannot go up. Okay, that is against the gravitational force. But now the bucket is coming up, means what? It is against gravitational force. It is not easy. But because of the presence of pulley, it is very easy for her to draw the water. Now next point, machines help us to save time by increasing the speed of work. For example, a scooter is a machine that helps us to reach far off distances in lesser time. Walking the same distance would take more time. Now for example, if you have to move around 3 kilometers, if it is by walk, means what will happen? You will have to use your energy and it takes more time for you to reach your destination. But at the same time, if you are going by a two-wheeler, what happens? It is very easy. You can move faster because the two-wheeler is a machine which will help you to cover the distance faster and with less effort. Coming next one, machines help us to do some jobs which are otherwise dangerous and unsafe. For example, we use a pair of tongs to lift a chapati from a hot tawa or a puri from hot oil. Isn't it? If these tongs means what you call hikla. Understood? If that was not there, it was not easy for you to just take hot things. To carry hot things, you require a help of the tong. See, to take a chapati from the tawa or to take a puri from the hot oil, can you just put your hand and take from hot oil? It is not possible, isn't it? So you have to take the help of a tong. Tong means like forceps it is. Now, types of simple machine. Lever. A lever is a rigid bar which can rotate around a fixed point or a fixed line. That is axis of rotation, known as the fulcrum. So you can see here, it is a rod here, and he wants to remove this big stone or boulder, what you call. So he has to remove this stone from there. What he does, he is giving a support of one more stone here, and on that he is keeping this rod which is going under this big stone which has to be removed. So when it just rotates here, what will happen? This will come up. Understood? So that is called as a fulcrum. See, a lever is a rigid bar which can rotate around a fixed point or a fixed line. So there is a fixed point here or a fixed line known as the fulcrum. So you can see. So you can see the fulcrum, and this is the rod here. In the above illustration, the small stone on which the rod rotates is the fulcrum. Here, this point. The weight to be moved is the load, and the force applied at the other end of the lever to lift the load is the effort. So here he is using his effort to move the rod on the fulcrum so that this load can be removed. This is a load now for him. Now, the weight to be moved is the load, and the force applied at the other end of the lever to lift the load is called a effort. So this is the effort. The distance from the fulcrum to the effort point is effort arm. From fulcrum to the effort, this distance is called as the, what is it? Effort arm. And the distance from the fulcrum to the load is the load arm. So this is effort arm. This from here to here is the load arm. Understood? So effort arm, load arm. A lever helps us to lift or move a large load with a small effort. If you want to try that to just take out the stone and put it out, it is not easy. So this one will help the work to be done easily. Classification of levers. Levers can be classified into three different classes according to the position of the fulcrum, load and the effort. Fulcrum, load and the effort. Okay. Fulcrum, load and effort. Class 1 or first order levers. A class 1 lever has its fulcrum located between the effort and the load. So what is happening? Fulcrum is where? This is fulcrum in between the load and the effort. That is class 1 lever. The direction of force changes in this type of levers. Application of effort downward. Application of effort downward moves the load up, while application of effort upward moves the load down. If you are just pulling it up, what will happen? The load will go down. If you put the effort downwards, the load will come up. That is the meaning here. So you can see here. See, what is this? Fulcrum. This is the effort and this is the load. Load means the, an object which you want to just push or pull. So what happened here? Fulcrum is in center, load is here and effort is here. That is a class 1 lever. Examples of class 1 levers are a crowbar, a pair of scissors, a wire cutter and a beam balance. You can see here. All these are first order levers. So if you are just taking this scissors, you are cutting. So what is happening here? Where is the fulcrum? In the center is the fulcrum. My fingers will be the effort and this will be the load. So that is what we call it as a first order lever. So you can see here, crowbar is there. okay, to lift the loads. Then scissors, then wire cutters and the beam balance, you can see it. Now coming to class 2 or second order lever. In class 2 levers, the fulcrum is at one end, the effort is at the other end and the load is in between. So you can see here, fulcrum is one end, effort is towards the other end, and where is the load? Load comes to the center. That is second order lever. Don't get confused. First order lever, fulcrum is between, load and effort to the sides. But in second order lever, what is happening? Effort and fulcrum will to the sides and load will be in the center. See, in class 2 levers, the fulcrum is at one end, the effort is at the other end and the load is in between. In this kind of levers, the direction of effort is not changed. Pushing up the lever arm will push the load. So what happens? The lever arm, you are going to just push it up. What happens? If it goes up, then what happens? The load will go down. So if you are putting effort here, the load will come down like this. Did you understand? So fulcrum and effort to the sides and load will be in the center. A wheelbarrow is an example of a class 2 lever. Other common examples are a screwdriver. You can see a screwdriver. You can see this. So with that, what you do? You have to just rotate the screw. Understood? So the effort is here and the load will be in the center here and the fulcrum to the other side. That's the meaning here. So a wheelbarrow is an example of a class 2 lever. Other common examples are a screwdriver, a catapult. Catapult means, you just tie a stone to rubber and it will have a handle. So if you just put that stone there and then pull it, what happens? You can just push the stone to wherever direction you want, isn't it? That is called as catapult. So a catapult, a nutcracker. Nutcracker, normally the old people, you see, to cut the, to crack the nuts means special arachnoid, adicate. Just to cut it, they use, no? That is what you call it as a nutcracker. A stapler, a lemon squeezer, and a bottle opener. All these comes under class 2 levers. So you can see here. So this is a juice maker. You can see that lemon juice maker. Screwdriver is there. Stapler. You can see this wheelbarrow. And here nutcracker is there. Catapult. See, this is catapult and bottle opener. So these are all the second order levers. Now coming to third order, in a class 3 lever, the fulcrum is at one end and the effort is applied between the fulcrum and the load. So what happened? Fulcrum comes to the end, effort in between, load to the side. So load and fulcrum is to the sides and effort becomes in the center. So here, in this kind of lever, the direction of effort is not changed. So effort is not changed, direction is not changed. The load moves in the same direction as the effort. So if you are not changing the direction, what happens? The load also moves in the same direction. A fishing pole is a class 3 lever. Our hand at the end of the pole is the fulcrum and the fish we catch at the opposite end is the load. The hand we place in between the fulcrum and the load applies the effort. So you have seen the fishing, what I call it as pole, fishing pole. So what happens? Our fishing pole, you are near the pond or river, you just sit in on the banks and then you just put that pole and one end will be in your hand, the other end fish will be there with the hook, it will be there. So that is what is meaning here. The hand we place in between the fulcrum and the load applies the effort. Other examples of class 3 levers are the human arm, a pair of tongs, a broom, a bread cutting knife and a shovel used to lift mud. So you can see here, this is a shovel, this is a knife, here you can see the arm and this is the broom. So all this comes under class 3 levers. So here one is that activity. Collect some levers used in your home with the help of your parents. Identify the effort, load and fulcrum in each. State the order of lever in each case. So let me stop it here, children. We'll continue in the next class.